Let me take a couple of minutes and give you some hints regarding the second AP practice question involving random variables. If you haven't read the question already, take a moment and read the setup at the top and read all three parts of the question. Pause the video before you do so, and then afterwards restart it and I'll give you some hints. This situation is a binomial situation, and it's really part B that gives me that final hint. So I'm selecting a simple random sample of 2,000 new car owners. So I have a fixed number of trials there, and I'm going to calculate a probability. How likely is it that fewer than 12 of these 2,000 will be owners of this particular model? So I can calculate a probability of success by comparing the number of Model E that have been purchased to the total. I have my fixed number of trials. I have my fixed probability of success. The independence condition we would have to assume here, but there are only two outcomes. Either Model E was or was not purchased by the individual selected out of the 2,000. So you don't have to justify all of those conditions here, but it's something worth reviewing. So how likely is it that fewer than 12 owners of Model E will be included in the sample? So I want to justify that X is distributed binomially. So you would need to know what your fixed number of trials are and determine what your fixed probability of success happens to be. And then you can find then the probability that you have a count of successes that's fewer than 12. So that's something you can do pretty easily on your calculator. So, and because now we know that it's binomial, it's not particularly hard to find the expected number of owners of Model E. That would be mu. And the standard deviation of the number of owners of Model E, that would be sigma. So you should have formulas for calculating mu and sigma for a binomially distributed random variable. So you need to know what n is. That would be our fixed number of trials, the 2,000. So the other value that you need is your fixed probability of success. And as I suggested before, a success would be someone that owns Model E. Well, what proportion of the owners actually own Model E? I claim you can estimate that probability of success by just looking at the 2323 and comparing it to the total of 297,354 owners. I would go ahead and change this into a decimal. I'd keep at least 3 decimal places and round it off. That's just fine. So that's a good reason why it's important to show work, even as simple as showing a fraction, showing the way that you're rounding it off, showing how you're using it in the formulas when you calculate the standard deviation and the mean or the expected value. And then the last part of the question is a good review question. The company is concerned that we would include fewer than 12 owners of the newest models that this company is producing, Model D and Model E. So by briefly, just a sentence or two, describe a particular sampling method. So you want to be specific about the method that you are choosing for selecting these 2,000 owners so that you make sure you get at least 12 owners for each of the 5 car models. So again, a couple of sentences there is more than enough.